Yeah, hello friends. Here I have come up with a question from thermodynamics. The students have been continuously asking in my WhatsApp, through WhatsApp they have been continuously asking this question actually. Yes, it is a very beautiful question recently asked in NEET actually. So let me just go with the question. They have given standard entropies of x2, y2 and xy3 are 60 joule Kelvin inverse mole inverse, and then for this is for x2, and for y2 they have given 40, and then for xy3 they have given 50, and then they have given a reaction also. By taking the help of this particular reaction, we need to calculate the temperature, and then delta H is also given, and there is a condition also given, equilibrium. And now by observing this, I am repeating the question. So standard entropies of x2, y2 and xy3 are 60, 40, 50 joule Kelvin inverse mole inverse respectively. For the reaction, half x2 plus 3 by 2 y2 gives xy3, and delta H is also given minus 30 kilojoules. This is very important to be at equilibrium, and the temperature will be. So to solve this question, we need to bring out delta S value. Sir, first of all, let us understand the question, and then let us just write down the given data. Okay, yes, they have given delta H value, it is minus 30 kilojoules. And then they have given delta S for x2 as 60 joule Kelvin inverse mole inverse, and then for y2 it is 40 joule Kelvin inverse mole inverse, and for xy3 50 joule Kelvin inverse mole inverse. And they have given an equation, half x2 plus 3 by 2 y2 gives xy3. Sir, in order to find out this particular delta SR, we need to take the help of this particular equation. So when we have products entropies and reactants entropies, then we need to use this particular equation. By taking the help of this products entropies and reactant entropies, by substituting those values, we are going to get the resultant entropy. The resultant entropy of the reaction, that can be defined as summation of products entropies minus summation of reactants entropies. And see here, in order to find out this resultant entropy for the reaction, we need to consider the stoichiometric coefficients also. Sir, here the products stoichiometric coefficient is 1, that is xy3 coefficient is 1, that must be multiplied into the given standard entropy of this particular xy3, which is 50, minus of this is, again we have two particular reactants whose stoichiometric coefficients are 1 by 2 and then 3 by 2. Here this x2 entropy must be multiplied by with half, and then y2 entropy is multiplied with 3 by 2. So here by substituting those values, we are going to get the delta S value is going to be minus 40. Okay, I hope you understood. Yes, minus 40. And then next, sir, here the delta H value is directly given in the equation or question, and then here we need to find out delta S. So delta S also we have got through that particular equation, and then next by substituting these two values into this Gibbs free energy equation. Sir, Gibbs free energy equation is generally given as delta G is equal to delta H minus T delta S, where there is a condition given, that is at equilibrium. So we know that at equilibrium delta G, that is change in Gibbs free energy, is going to be 0. And now by substituting that, we are finally going to get this T is equal to delta H by delta S. Now by substituting those values into this, where delta H is given minus 30 kilojoules, but the value of delta S we have in joules. So please convert that into joules, that is minus 30 into 1000, minus 30,000 by just now we have got the delta S is minus 40. By dividing those two values, we are going to get temperature is equal to 750 Kelvin, and that's our answer. We need to go with 750 Kelvin among the given 4 options. So thank you for watching. That's all in this video. Soon I'm going to come up with a next video with a very beautiful question. Thank you.